Hello beautiful scholars, welcome back to the channel. Today we're going to be subtracting fractions, mixed numbers. For each of the fractions I have here, I'm going to show you two methods how to subtract them. The first method will be subtracting the whole numbers and subtracting the fractions and then combining those answers. The second method will be changing the fractions to improper fractions first and then working them that way. So for each of these, I'm going to do the two methods. Alright? Some teachers might specifically want you to use this method or that method. So, and there are other methods too of adding mixed numbers. So I want you to know these two basic ones that are used. So we have 3 3/4 and we're subtracting 2 1/2. So the first method, we're going to subtract the whole numbers. 3 take away 2, that gives 1. We're going to put that to the side. And we're going to find the LCM of 4 and 2, which is 4. Now we're going to say 4 goes into 4 once. 3 times 1 gives 3. 2 goes into 4 2 times. 1 times 2 is 2. 3 take away 2 is 1, and we put that back over the denominator. And finally, we go for the whole number that we had put aside and include that with the answer. If you're not familiar with how to change mixed numbers to improper fractions, how to change improper fractions to mixed numbers, how to reduce fractions, and how to find the LCM, each of those topics that I just mentioned, each one was featured in a video of its own. So you can go and look those up, bring yourself up to speed so that you know how to proceed with this video. So now we're going to use the second method, which is to change the fractions, the mixed numbers, to improper fractions first. So 4 3s 12 plus 3, 15 over 4. 2 2s 4 plus 1, 5 over 2. We're still going to need to find the LCM of 4 and 2, which is 4. 4 goes into 4 1 times, 15 times 1 is 15. 2 goes into 4 2 times, 5 2 is 10. And 5 take away 10 is 5 over 4. And finally we change that back now because this is an improper fraction. We don't usually leave our answers in that form, so we change it back to a mixed number. 4 goes into 5 1 time, remainder 1 over 4. So you see that whichever of the methods you use, you should get back the same answer. They are just different routes to the same destination. This method is it will give you bigger numbers, right, to deal with. So I personally prefer the first method. However, your teacher may specifically want you to use this method, or you may prefer this method, right? So I'm showing you both ways of working. So 5 1/2, sorry, I'm going to change this to 8. 5 1/2 minus 3 1/4. So 5 take away 3 gives 2. The LCM of 2 and 4 is 4. 2 goes into 4 2 times. 1 times 2 is 2. 4 goes into 4 1 time. 1 times 1 is 1. 2 take away 1 is 1. And now we need to add back the 2 that we had put aside. So it's 2 1/4. Or we're going to change the mixed numbers to improper fractions. So we say 2 5s 10 plus 1, 11 over 2. 3 4s 12 plus 1, 13 over 4. Find the LCM of 4 and 2, which is 4. 2 goes into 4 2 times. 11 2s, 22. 4 goes into 4 1 time. 13 1s, 13. 22 take away 13 will give 9 over 4. And 4 goes into 9 2 times, remainder 1 over 4. So again, we see we got the same answer. Whichever method we used, we ended up with the same answer. So it boils down to either what you prefer or what you are specifically asked to do. Alright? So let's go again. 2 3/4 subtract 1 1/2. 2 take away 1 is 1. The LCM of 4 and 2 is 4. 4 goes into 4 once, 3 once, 3. 2 goes into 4 2 times, 1 times 2 is 2. 3 take away 2 is 1, put it back over the 4, and we have 1 1/4. Okay, so we got the same answer as number 1, right? Or, let's work it the other way. 4 2s 8 and 3, 11 over 4. 2 1s 2 and 1, 3 over 2. LCM is 4. 4 goes into itself once, 11 once, 11. 2 goes into 4 2 times, 3 2 is 6. 11 take away 6 is 5 over 4. And 4 goes into 5 once, remainder 1 over 4. So we got back our same answer. Sometimes you can use different methods to check if your answer was correct. If you have the time, so maybe you'll use the method that you prefer or the method that your teacher asks for, and then you can go to the side and use the other method just to double check to make sure that your answer is correct. Alright, so we have 3 more fractions to work, and we're going to work each of them using the 2 methods. So we have 2 7/8 minus 1 1/3. 2 take away 1 is 1. LCM of 8 and 3 is 24. 8 goes into 24 3 times. 7 3 is 21. 3 goes into 24 8 times. 1 times 8 is 8. 21 take away 8 would give 13. Over 24. And we need to put the 1 in front. Remember this whole number that we put to the side. A lot of students forget, right? A lot of students forget to go back for the whole number. And so they write this as the final answer, which it is not. Okay? Alright. So it's 1 13 over 24. Alright, so we're going to try the other method. 2 7/8 minus 1 1/3. So now we're going to change them all to improper fractions and work it using that method. 8 2 16 plus 7 23 over 8. 3 1s 3 and 1 4 over 3. The LCM of 8 and 3 24. 8 goes into 24 3 times. 23 times 3. 3 3 is 9. 3 2 is 6. 3 goes into 24 8 times, and 4 8s are 32. 69 take away 32. 9 take away 2 is 7. 6 take away 3 3. Alright, so 24 goes into 37 once. And if we take 24 from 37, we end up with 13 over 24. So this proves that our answer was correct. We got the same answer. Remember, it's different routes to the same destination. Different ways of getting to the same place. It's not that one is superior to the other. You may prefer one. I personally prefer the first method because when you use this method, you work with smaller numbers. It's an easier method for me because smaller numbers will have less errors occurring. When students are working with bigger numbers, not that we're scared of bigger numbers, but it's just a reality. The smaller the number, the easier it is for you and the less mistakes you'll make. The bigger the number, the more you're likely to make an error in your calculation, especially at this level where you don't use calculators. Alright, so 2 and 2/5, subtract 1 and 1/7. 2 take away 1 is 1. The LCM of 5 and 7 is 35. 5 goes into 35 7 times. 2 7s 14. 7 goes into 35 5 times. 1 times 5 is 5. And 14 take away 5 is 9. We put that back over the 35. Finally, we go and get the 1 that we had put to the side. So it's 1 and 9 over 35. Or, working the other method, 5 2's 10 and 2 12 over 5. 7 1 7 and 1 8 over 7. Still finding the LCM. 5 into 35 7. 12 7s 84. 7 into 35 5. 8 5s 40. So we end up with 44 over 35, which is an improper fraction, so we want to change it back now to a mixed number. 35 goes into 44 one time, and we have 9 remain, 9 over 35. So 1 and 9 over 35, which is what we got using the first method, and you should get the same answer. Alright, so the final pair of fractions that we're subtracting, we have 3 and 4/5, and we're subtracting 2 and 1/3. Alright, so 3 take away 2 give 1. LCM of 5 and 3 is 15. 5 goes into 15 3 times, 4 3 is 12. 3 goes into 15 5 times, 1 times 5 is 5. Wait, 12 take away 5 is 7 over 15. And these fractions cannot be reduced, or we would have reduced them. Finally, we go and get the 1 that we have put aside. So it's 1 and 7 over 15. Okay? And now we're going to try it using the other method. So we write back our fraction. 5 3 is 15 and 4 19 over 5. 3 2 6 and 1 7 over 3. The LCM is still 15. 5 goes into 15 3 times, 19 times 3. 3 9s 27. 3 1s 3 and 2 5. 3 into 15 goes 5, and 5 7s 35. So when we subtract, we get 7 take away 5 2, and 5 take away 3 2 over 15. 15 goes into 22 one time, remainder 7 over 15. Alright, so we have proven that we can use both methods, get our answers, the same answer, right? Whichever method we use, we get the same answer. Whether we're working by subtracting the whole numbers first, working the fractional part, and then combining those answers, or changing the fractions to improper fractions, then finding the LCM and just working all of that, right, as one. We'll end up with the same answer. It's always good to know more than one method if you can. You know, if those methods exist, familiarize yourself with different ways of working things. Don't lock yourself into one method and think this is the only way, this is what I'm going to do, I don't want to hear anything else, I'm going to be confused. You don't need to be confused. I have literally heard students and teachers say they don't want to learn any other way to do it because it's going to confuse them. I've heard parents say the teacher at school teaches this way, nobody else should teach a child another way because the child is going to be confused. No, the child, in my opinion, should grasp the concept more, the more methods that the child is exposed to. you should grasp the concept more, and you should be able to alternate and work with different routes to the same destination. It should not confuse you. If you are confused, that means you don't really get the concept in any of the methods. So expose yourselves to different ways of working the same problem. So I've taught you 2 ways. There are other ways of adding fractions, and you can expose yourselves to them as well. Go and do some research and find out. These are the 2 most popular ways that I've seen, right? And I wanted to make sure that you are versed, you are versatile, you can switch, you can choose which one you want to use. Right, so if you have been helped by this video, I would just love for you to comment and say thank you, miss. And I'd also love for you to share the video so that other students can benefit from the information just like you did. If you have not subscribed to the channel, please do so. And I would love for you to comment and let me know which topics you'd like me to do videos on. If you check the catalog and you don't see that topic, because we have dozens of videos already and we're going to keep adding. So just check the catalog first, but if you don't see what you want, please comment and let me know, and I'll certainly do that video for you. My scholars, I'll see you in the next video.